All right, so let's put it all together. So we can write formulas now for compounds that include polyatomic ions. You have to know those 11 polyatomic ions, but once you know them, you can write formulas. So for instance, I can take something like ammonium chloride and come up with a formula. Ammonium chloride, I don't know what word was coming out of my mouth there, can be used to lower the pH of your blood. It's acidic, so if you've got respiratory alkalosis, you can push some intravenous ammonium chloride and it will cause the pH to drop down again into a more healthy range. And it's an ionic compound that contains a polyatomic ion. Ammonium is NH4. Do you remember the charge? It is +1. Chloride. So chloride, we can see, consists of chlorine. So Cl, that IDE ending lets us know it's an ion. And chlorine is in group 7. It's 1 away from the noble gases, so its charge is 1-. The golden rule is they come together 1 to 1. Sorry, the golden rule is they come together so that the charges cancel out, which in this case would be 1 to 1. You can do the swap down method too, that gives you a 1 to 1. And so this would give a formula of NH4. We always write the cation first, Cl. And remember, the pluses and the minuses, they canceled out when they came together, so we don't write them down here. So this would be the formula of ammonium chloride. Now, here's another interesting compound, magnesium sulfate. And a chemist typically uses magnesium sulfate to dry things. It has an affinity for water. It tends to pull water out of organic things dissolved in organic solvents and helps to dry it out. So that's what I've always used it for. Now, when my wife was pregnant, she went into labor something like 6 weeks early. So they pushed a drip of magnesium sulfate. And I looked at it, I got so excited. I'm like, I know what that is, right? And I'm like, what are you giving it for? So it turns out it stops contractions, it slows them down, and 6 weeks early was a little early, but he turned out just fine. And it's also an ionic compound made of a polyatomic ion. Magnesium is Mg, it's in group 2. I wonder if you remember what that group is called. Do you remember? It's the alkaline earth metals. A lot of people forget and get it mixed up with the alkali metals, but it's alkali metals group 1, alkaline earth metals group 2. Sulfate is a polyatomic ion, and it's the normal one, as opposed to sulfite. That's got 1 fewer oxygen, so it's SO4 2-. And again, we could do the swap down, right? We could do the swap down and take the 2 down and the 2 down, but we remember 2 to 2 can be simplified as 1 to 1, so we don't actually have to do that. So we just need 1 of each, so MgSO4 would be the formula here. And I can do one more. In fact, maybe I can give you one to do. So how about something like calcium carbonate? So pause the video and write the formula for calcium carbonate out. Okay, if you've unpaused, calcium is Ca2+, it's in group 2, carbonate CO3 2-. So just like before, they have equal and opposite charges. So 1 to 1 is totally fine. So CaCO3. Okay, let's go to a new slide. So what happens if it's not 1 to 1? So if we had something like sodium phosphate, which is a really great cleaning compound, actually. So TSP is what it's sometimes called, but I won't tell you what that stands for. But sodium phosphate. Sodium is a metal. It is in group 1A, so if it's an ion, it'll be 1 positive. Phosphate is a polyatomic ion, PO4. And what's its charge? Do you remember? It's the only one with its charge that we looked at. It is 3-. So if we do the swap down method, the crisscross method, the 1 would go here, which we don't write. The 3 would go here. So we would write it as Na3PO4. Okay, we can kick it up a gear. So here is one that is decidedly more complicated. And imagine we had something like calcium hydroxide. So calcium is a metal. Hydroxide is a polyatomic ion, so in the section here, it's not enough just to know it's metal and non-metal. You got to recognize those polyatomics. Calcium, from where it is on the periodic table, you should always sleep with your periodic table on your pillow, by the way, is in group 2A, so it's got a 2 positive charge. Hydroxide is a polyatomic ion, OH-. We can do the crisscross method, so we take the 2 and the 1 down. We don't ever write the 1 in, so we have Ca1. And we have OH. And here is the problem. when we write the 2 like that, the 2 technically only refers to what it's right next to. But we actually want 2 hydroxides. And the reason we want 2 hydroxide is that for the charges to cancel out, right, we need 2 of these polyatomic ions. These polyatomic ions come as a group of atoms with a charge. We can't split them up, so it's just like a cat, right? You might really like its tail, and you might really want to pet its tail, but you got to leave it attached to the rest of its body. So that's kind of a weird analogy, I know, but you can't break this up. You got to keep the O and the H together. And the way we've written the 2, there's only 2 of what's next to it, the H, but we also need the 2 O's as well. So the way we're going to do this is we're going to use parentheses. So when there's more than one periodic, or more than one polyatomic ion, we use parentheses. So we have 2 OHs, so we're going to put the OH in a parentheses, right? An open and a close, and we write the number alongside it, letting us know how many we have. So that's the trick to that. So let's try one more. And here's one maybe you can have a go at. So how about something like aluminum nitrate? So let me write it out, and why don't you pause the video and have a go at this one. Okay, if you've unpaused it, aluminum is Al. It is in group 3. It is a metal. Okay, it's not a heavy metal or a transition metal, so it only has 1 charge. That reminds me, we should probably do one that has a variable charge in a minute. Nitrate is NO3 minus. Okay, so now if we crisscross the 3 and the 1, okay, the 1 we can pretty much ignore, so it's Al. But here we have 3 NO3s, and if we write the 3 like that, it looks like we got an N, and we got 33 O's, but we actually want 3 NO3s. So the trick to that, right, is, and on the exam, right, you don't need a different color for the parentheses, but it shows up better here. It's just to put it in parentheses and write the 3 next to it. So that is that. And so how about a challenge one? So a challenge one, how about something like copper 1, ooh, what would be a good one? Carbonate. I wonder if you can go ahead and pause and write down the formula for copper 1 carbonate for me. Okay, if you've unpaused, copper 1, Cu+, remember it could be called Q+, carbonate, CO3 2-, and again, we can trade these down, the 1 and the 2. Now here's one where Cu2, it is okay to write the 2 here because 2 refers to the copper. It's not a polyatomic ion. The carbonate, okay, now some people get obsessed with the parentheses, but because you've only got 1 carbonate, you don't need to put it in parentheses ever. So Cu2, CO3 would be totally fine here.